Hey, my name is Patrick, and today we're going to talk about the good, the bad, and the ugly of this Veri-Rite valve. So, as always, first we're going to talk about the basic principle of how this valve works by looking at the internals of it. So, the fundamental principle of the valve, air valve on a steam system is that it attaches to the side of the radiator. It's as simple. You basically screw it in, and then when the steam enters the radiator by definition is filled with air. The steam tries to push the air out from the radiator. To do that, you need to have some kind of opening. So in theory, you could just unscrew this valve, leave the opening. Again, don't do that, but that's the theory. You could have the opening out there, and then the steam would push out all the air out of the radiator, thus keeping the radiator warm. The only problem with that solution that you shouldn't do is that opening also would allow all the steam to escape from the radiator. So because of that, we put, instead of that, you're leaving that opening open, we put the valve in there, and that valve's function is to both do a few things. One is to allow the air to escape from the radiator, and two, when the steam enters this valve, so that means it's surrounding the internals of the valve closes, closing the steam shut inside the radiator. So now the steam can give off its heat to the metal of the radiator, and then in the process it can also condense. When that happens, the condensate occurs, and then that gathers at the bottom of the radiator, and the condensate flows back to the boiler via, let's hope, the properly pitched radiator opening. So that's the principle of why we need those valves, and then let's just look at the internals. So again, this is our thread of the valve right here. So the air enters here, being pushed through the steam, and then it flows past this metal bellows inside that's filled with some kind of mixture of expendable, I guess, alcohol and something, and then it travels up and goes through this small little opening up here, and then escapes at the radiator. And then when the steam finally enters, instead of air, but rather the steam enters this opening, then it surrounds this metal bellow, and then the metal bellow, the material inside expands, and there's like a bottom part where it kind of flips in and out. So it starts like this, and then expands, and does this, and with that it moves this whole bellow up with this needle, and then it closes this little opening up there, and de facto trapping all the steam inside, so that now the radiator is close to the atmosphere. It has this little dial at the bottom of it. The dial is attached to a screw, and the screw, when you move this dial in and out of screws, they're very basic. Like the screw, it's a righty tighty, lefty loosey. So when I go to the counter clockwise, then I'm screwing this screw, and in the process I'm lifting this bellow slightly, so this bellow gets a bit closer to this opening up here. And then when I do the counter clockwise, then I screw out of this screw, and then this bellow gets farther away from this opening, and with that you can control the venting rate. So that means this opening gets, because of this needle, gets either smaller or larger depending on which setting you're choosing. Again, they numbered this screw right here, this dial, from 1 to 8. This is not a precision marking, so it's like when you take two of those Vent-Rite air valves, and let's say we set them both at, let's say for the sake of discussion, 5, that doesn't mean they're going to vent at the precise exact same rate. Again, so it's more like just give you just general understanding of, yeah, okay, 5 clearly should vent a bit faster than, let's say, 1. But again, this is not like precise scientific venting rate, just for your general information. Cool part aspect of it is also has this metal thong right here, so that when the thong is inside, and then it allows all the metal condensate, all the condensate that gathers on the metal surfaces to easier flow out of the valve, so that there's certain gravity, so that the valve stays relatively dry. As much as I want to love this valve, I don't particularly. I'm a bit indifferent. So on one hand, the cool part of it, that let's call maybe the positives, that you can, when you screw it all the way in, then usually it closes this, usually, which means based on manufactured tolerances, most of the time, let's call it, let's say 2 out of 3 times when you get this valve, it does that. So basically that means you close completely. So if I were to go blow on this valve right now, I should have nothing coming out of it. Let me just try it. Yep, I tried it. Indeed, there's nothing coming out of it. Let me just open a little bit so you can hear the maximum opening, what this sounds like. All right, no, actually, no, it's actually releasing some when I screw it all the way in, it releases some air. But at the same time, you could see the difference between from wide open, the sounding quality from wide open to so-called wide close. So in other words, the sound quality does change depending on which opening you have. And it's a basic physics. You have a small opening through which you push the air. It's like a whistle of some sort. It will create some sound. Because of that, this valve tends to be relatively loud in terms of air expelled. If you kind of compare those two openings, let's say, let me just see, make sure that those two openings, this is much bigger opening, it's much smaller opening. So by definition, if you have the same amount of pressure, the same amount of air being expelled from those two openings, this one, no matter how wide open this dial is, this one is gonna create a slightly less loud of a sound than this one because this tight smaller opening. That said, though, it doesn't have the gargling, the water inside, liquid inside, the gargling sound like this valve. Even when it's a working valve, then this does produce lots of gargling of the condensate inside the valve. This one doesn't tend to do that. So in that sense, it's quite loud in terms of this air. It's very quiet in terms of gargling. This one also because of this metal bellow right here that kind of stays like this and then stays like this when it's cold and then expands like this when it's hot. It sometimes creates this popping sound each time. It kind of has this metal distortion from one direction to the other. It can be quite loud, actually. Don't particularly enjoy this popping sound. So in that sense, I'm not really in love with this valve, even though it has relatively between all the other valves that I'm showing, this has relatively low failure rate. So that means all the metal parts, of course, besides this part, tolerances are quite tight. So even this one, even though I showed you that, even though when you close it all the way, it does release a little bit of air, but I almost guarantee you when this internal component gets heated up, this valve will still close. So in other words, the tolerance is allowed for that. Yeah, I think it's a on one hand great valve. Try it out. So yeah, Vent-Rite number 1. All right, that's that. So I would say ultimately for this valve, thumbs up because it's a good working valve, and it's personal preferences that give this valve thumbs down. So thumbs up.